Good evening, everyone. In the last session, we are trying to discuss about this particular tree map here. We identify this particular put method, how it is working internally. So same way, we identify the some other important information about the submap, head map, as well as this particular tail map. So these are all the different three maps we are having. This particular three map internally, what they are doing it. So it is trying to copy the element based on this particular order here. Okay, so submap basically it is trying to copy the from starting element to ending element. Whenever we are trying to providing this particular tool, so this particular true, it will try to include the all the last element whatever we are making the condition here. Okay, so this is the same we identified head map and tail map. Now if I'm going to open this particular another method, what we need to discuss inside this particular tree map. Okay, now here what I'm doing is, let me go to this particular navigable map. So inside the navigable map, we discuss about the particular sub map, head map, and tail map. We'll discuss about the first key, how this particular first key it is implemented internally. If I'm going to call tm dot first key, sorry, first entry, there is no, okay, first entry, and we have a first key also. Okay, we'll see first key only. First, we'll go for the first key. We'll identify how this particular first key implemented internally. This is one of the important example we need to understand, because these are all the object we inserted inside this particular tree map. How this particular tree map is going to use? First, we are going to have one root record. This particular root can contain the left and right objects here. Okay, so this particular right and left record can contain the same left and right. So this is the structure it is going to follow internally to insert this particular tree map record. Now we'll identify using this particular tree map how we are going to load this particular first key here. Okay, let me put a breakpoint here. I'm trying to run this particular example. Now if we observe, it is trying to stop at first key. Now I'm trying to move inside this particular first key, how it is implemented. Now if you see this, we are trying to call the one of the important example called get first entry. Okay, internally, whenever we are trying to call this particular first key and using this particular get first entry record, we are trying to load the first entry. From the first entry, we'll load the key information. Now, where we are having this particular first entry, here we are having first entry and last entry. So, using this method, we are going to load first key and last key. Now, what you need to understand, if we observe carefully these two methods, we can easily understand these two methods, first key and last key, because from the first entry, it will try to load this particular records here. Okay, this is one of the important example we need to understand here. Okay, now we'll go to this where we are stopping here inside this particular tree map. Now I'm trying to discuss about the first entry. Now inside the first entry, what we are doing here, we are trying to load this particular root. So root only can contain the all the left and right object here. So if I'm going to load this, if I'm going to load this particular object using our expression. So these expressions are very important here. Using this particular expression, I'm going to load root dot right here. Okay, root dot right. So what is the value we are having here? Now you can see R value. If I'm going to add same thing, root dot left. Okay, root dot left here. Now here you need to identify section. So inside this particular expression, you can easily understand. You can easily understand how this particular expressions are going to work internally. Okay, let's see the left record we are getting 25, the right record we are getting as a 47, and the key we are having R, and inside this particular left we are having A. Okay, if I want to load this particular first record, now what I'm doing, I'm trying to load this particular left records here, because left will contain the smallest value, the right side will contain the some highest values. So this is important, we need to understand how it is going to work internally. Okay, now you can see after this I'm trying to loop this particular objects with help of this particular while loop. Now just now we discussed here the p dot left. P dot left basically it is trying to store the same information whatever I'm trying to explain it. Store 25. Okay, a is equals to 25.5. So this object it is not null. Now we are trying to store into the p. So again this particular a is any record is containing null. So what is the smallest value? Or we can call it as what is the first value? Something like a is equals to 25, because this particular a cannot contain any the left record. If it is contained, so that record will be the smallest record. Okay, because we don't have anything. So now what you understand here, simply it is trying to returning this particular p. Now this is the first entry. A is equals to 25.5. But if we go to this, here the a we are having 12.3f, and here we are having 25.5. So what is the value it is taking? The line number 13, whatever the record we inserted, because here the key is same. Whenever the key is same, the value is going to override with the latest value. Because of that, we are trying to load the first record, the p containing here 25.5. So once we load this particular first entry, from the first entry we are trying to returning key. Now how we are returning this particular key? If this particular is null, we are going to throw an exception. Otherwise, e dot key. So the first entry getting the win. So or we can call it as a first key method. What happening internally? If the whatever the object we are returning, if it is null, it is going to throw an exception. Okay, this is the differences we need to understand for this particular first entry and first key. Okay, in our case it is not a null. Now because of this it is trying to return this particular key information. Getting the point? It is trying to return the particular key information. So this is one of the important example we need to understand how it is going to work this. Okay, this is all about the first key, how it is implemented internally. Now you can see we are trying to print this particular first key. Okay, if I'm going to write a sys out here, like a system.out.println, what happens internally? It is trying to returning this particular value, whatever the value it is trying to return, we'll understand here. Now you can see we are getting as a character. It is something like a key we are getting, not a value. This is important. We need to understand how this particular key it is returning, because what is the method we are calling? First key. Okay. Same way, do we have any values here? Do we have any method to return the first value? So now you can see last key and first key. We have a keys related section, but we'll see in the navigable map also we don't have any values related section. So we have only key related section here. So if I want to find out the last key, how we can identify this particular last key? Now simply you can call the system.out.println and tm.last key. So last key internally it will try to call the last entry. If I'm going to print this, so here you can see get last entry. Whenever we are trying to find out this particular last entry, what we can identify here? Here we are going to use the p dot write here. Okay, p dot write. So this is important. For the first record we are using the p dot left, and for the last record we are trying to use this particular p dot write. These are all the main information we need to understand how this particular the first entry and the last entry and first key and the last key how it is working. So using the right side value we can easily understand how it is going to print the last value. Now I'm trying to restarting this. So we identify the first key. Now I'm moving into the last key. Now you can see we are calling the last entry. Again I'm trying to check this particular last entry. The same root record we are going to load, something like the C record 14 dash something we are having the value 14.6. So after loading this particular record here what we can identify? P dot write. So what is the P dot write value we are having? Something like 47. So this is the loop is going to repeat. Now the P dot write is set to this particular P. After this, now what I am doing is we are trying to load T record. So and T if it is contain any the right side record, again it will repeat the loop, otherwise the T record will return. So now you can see T is the highest record. Getting the point? Whatever the T we are passing, the T is the highest record here. This is we need to understand. Now you can see here we are trying to return this particular T record. This is we need to understand, and from this particular T again we are calling the same key method. It will return the particular key. So if it is the object, if it is null, it is going to throw an exception. Here it is trying to throw an exception when this particular E is null. Okay, in our case it is not going to throw any exception. Simply it is trying to return this. So this is the last key. First key is a and the last key is a T. Okay, so this is the order we need to understand. Now after this key set, so it is a simple one because we already discussed this particular key set, how it is going to print. Now here I'm trying to print this particular key set. Before going to print, because okay, let me. So key set I'm trying to print. The key set basically it will return only set of keys. Only set of keys it will try to return. Now if I'm trying to print this, it is trying to return this particular set of characters here. Now I'm not going to use this particular set of characters here. I'm trying to use the for each loop. Okay, here I'm trying to use this particular for each loop. So this is the way of using this particular for each loop, and you can print this particular key set. So what it will do internally, it will try to print this particular okay, it will try to internally load these particular values one by one. Now if I'm going to put a breakpoint on this particular key set, so observe carefully what I'm doing here. First method I'm calling first key, last key, and finally we are calling this particular key set. What exactly the key set is doing internally? It is trying to get in the button. It is trying to load only keys here. It will not load values, only it will load the keys. So how it is loading keys internally, we need to identify. Now you can see, now what is the method I'm calling? Navigable key set. Internally I'm calling this particular navigable key set. Now if you see here, this particular navigable key set is null. It will call this particular key set by passing this particular current object. What is the current object we are having? Tree map. Now what exactly it will do? After this particular key set, we are going to call internally the iterator. This particular iterator will return all the values. So now you can see this key iterator is going to call if it is a tree map, because we are trying to work on the tree map. Getting the point? And the key iterator is going to call. If I'm going to put a breakpoint on this particular key iterator, now you can see key iterator we are calling based on the first entry. Okay, based on this particular first entry. Now you can see here every time we'll call this particular next entry. If I'm going to put a breakpoint here, now it will call this. Okay, now you can see next entry method is calling internally. How it is calling here? The way we need to identify next entry method. Why it is calling this? Here we are calling the key set. Okay, here we are calling this particular key set here. Whenever we are calling this particular key set internally, it is trying to call the next method. From where it is calling this particular next method? Because we are calling the key iterator. Only it will iterate only keys. How it is iterating? We are going to call this particular next entry method, and each and every next entry it is trying to return the key. Okay, it is trying to return this particular key. Now observe we are calling the next. So what is the next? It is containing the first record. Okay, the C, this is the second record, because current record is C and the second record we are trying to load as a value. Now we'll see how it is working internally. We are trying to check the condition, and this condition is also not satisfied. We are calling the successor. This successor, now it will return the next record. Now if I'm going to show you this, what is the T I'm passing here? So something like here, now you can see a value 25.5. Using this particular a value, now what we are doing is we are trying to check this particular if condition. If we are having a right side value, it is checking. Otherwise, we are trying to check this particular parent. When the parent is having, now we are trying to check this particular condition. So this is the while loop internally. It is trying to execute this. Whenever it is executed, now it will try to print all the keys here. One by one, all the keys it's going to print. So what is this particular P? Where it is initialized here? Same, the parent record. Whatever the parent record we are having. Why the two records? So which two records we are trying to discuss here? So you're talking about which two records here? Last two records. So you're talking about these two, 17 and 18, E and R. Yeah. So E and R, basically E is coming. Okay, R is also coming. And R 47 9F it's coming. Correct only. The last record. Okay, and E 58.8. So whatever we are discussing, 58.8, it is coming. See, the order, this is important. The order is important because if you compare with the comparative method, T will contain the highest Unicode value. Okay, and A will contain the smallest Unicode value because A will start with 65 and this particular T will end with something like around 90 or 90 something. So in the 90 range, we are going to get this particular character for the Unicode value for this particular character T. So it will not allow the duplicate. So that is only that I'm explaining, right? Because in the last section also we identified if we are having the same key, it will override the value. Because of that, here if you see, A here we are trying to store, and here also we are trying to store this particular same A. But whenever we are trying to store in the both location, this value override with this particular value. Because of that, we are getting A value 25.5, not the 12.3. Not to 12.3. So this is important. So this is only I'm trying to explain here. Okay. So is it clear? Any questions? Okay. This is, we need to understand how this important method like put method and first key, last key, key set internally, we come up with a key iterator. The key iterator, it will try to return only keys. Because of that, if you see here, only keys we are getting. Getting the pen, only the keys we are getting. This is important, we need to understand here. Getting the pen. This is only the important information we need to understand. Because of this, we are getting the keys. Now, if I'm going to show you another important information, values. It will try to return only values. It will not return any keys information. Now you can see here I'm going to return one more loop. tm dot values I'm trying to return here, and it is trying to return the collection type. So float, now if you see carefully, it is trying to return the float. Float is basically value type. And here the character we define, it is a key type. Getting the point. This is important, we need to understand how it is going to work. And after this, now what I'm doing here, I'm going to discuss about this particular collection. And here I'm trying to remove the float, and here the generic type also I'm trying to remove. And here I will print this particular values. Okay, now if you observe the both for loops here, first one it will return the keys, and the second one it is trying to return the value. Now you can see these are all the values. Okay, so first loop it is trying to return the keys, and the second one it is trying to return only values. So these are all the purpose of this particular method. The key set method, how it is working, and values method. The key set internally, it is trying to return the key iterator. The values internally, it will return the value iterator. So we already identified like how we are having this particular iterator classes. Now if I'm going to show you, this is the key iterator, and above we are having value iterator. Now you can see here we are trying to return the value, and here we are trying to return the key. Okay, so based on this particular two iterator, we are getting the specified values. If you want to load only keys, you can call the key set, and if you want to load only values, you can call the value iterators here. Okay, these are all the two important methods we are discussing here. And after this, now what is the another important section? Entry set. So entry set, basically it will return the record object. The record will contain key and value pair. Okay, the entry set, basically it will return the value pair here. Okay, it will return the value pair, but here we are trying to return the key and value, but this entry set will contain the one of the pair object. The pair will contain the key and the value. Now we'll see how it is going to return this particular tm dot entry set here. Okay, entry set, now it is containing set of, it is containing entry character comma float. So each entry we are going to store inside this particular set here. Now I am trying to removing this particular set, and I will provide the for loop here. Now after this, what you can understand here, this is we need to understand. This is the for loop we are going to use to store this particular values. So now observe carefully how I am trying to store this. And here, okay, entry set dot get key, or what is the method we are having? Entry set dot what happened? Let me save this. We need to discuss what is the method is available inside this particular entry. Entry basically will contain key and value. Now if I'm going to provide this, so it is the interface we are having. I will print this entry set. We'll see how these records are having internally. Okay, after printing this particular keys I'm printing, and later I'm trying to print this particular values, and this record will contain key and value. So first record, second record, third and fourth, like, but here now you can see it is a one of the entry record. Get independent. So entry is containing key and value. So key and value, get independent. But this information from where we are getting it? This information we are getting from this particular loop here, whatever the loop we are trying to repeat here. Okay, these are all the three important information we need to understand regarding this particular tree map here. So this is the first method, key set, values we are having, and entry set. These methods are coming from the where? So I hope it is implemented inside this particular map also. Okay, key set, values, and entry set. So inside this particular value, map interface only, these methods are having. So these three methods are defined inside this particular map interface. Okay, inside this particular map interface here. Okay, so now what we need to understand here? Now what we need to understand, based on this particular method, we can try to load the keys or values or entry record. Now the sorted map, whatever the sorted map we are having, all the example we identified here. Now I'm trying to move the navigable map. So this is the navigable map we need to understand, and we identified first entry and last entry. So we need to discuss about the pool first entry. How this particular pool first entry it is going to have. Okay, how this particular pool first entry it is going to have. Now I'm trying to comment out this, and internally, so here only I'm going to print this particular values. tm dot pool first entry record. So this is important. Pool related method and peak related method. Now you can see somewhere this interface cannot have that. Let me check. Any methods we are having tm dot. Okay, so right now we don't have any the peak related method inside the navigable map, but this peak related method we already identified in the some other collections and some other map related example. Okay, so observe carefully. Now what I'm doing here, I'm trying to call this particular pool first entry. Okay, what is the difference between first entry as well as pool first entry? Now we need to understand these two, the differences internally. Now I'm running this example. Now you can see I'm calling this particular 21. So first key and the last key. After this I'm calling this. Now if you go to this, internally what is the method we are calling? Okay, internally what is the method we are calling? So this is important. Again we are calling the same get first entry. Where we are having this particular get first entry? Here, now if you see this first entry. Okay, get first entry internally. If you go to this, so it will try to call this particular first record, and we are trying to load this particular root, and so it's trying to load this particular left side. First record is trying to load. Where is that method is identified? Get first record. That we did not discuss. Okay, it is a public method. Okay, so this is not a public method. Getting the point? This is not a public method. Finally, what we identified, whenever we are calling the first entry, internally it will try to call this method. Okay, first entry internally it is calling this. Now let me open that. Now you can see first entry method I'm calling here, and internally get first entry we are calling. Okay, internally we are trying to call this particular get first entry. Same way, now whenever I'm calling this particular pool first entry, whenever I'm trying to call this particular pool first entry record, internally it is calling this particular get first entry, and later, get the point, and later we are loading this particular entry record, and after loading this particular entry record, so we are trying to call the export entry. Export entry. So what exactly it will do? This particular export entry. Now we need to understand this. So this is the export entry. If it is null, will return null. Otherwise, we are calling this particular abstract mag dot simple immutable entry. Okay, we discussed the string related section. String is also one of the immutable class. Same way, this is also immutable entry. So once we insert this, we are not going to modify. Once we are trying to modify, we need to create the one more object to reflect the current changes here. Okay, to reflect the particular current changes. So these are all the very important information we need to understand how it is going to work internally. Okay, so simply the whatever the E we provided, it is not a null. Here now you can see it is not a null. So whenever it is not a null, what we are doing is we are going to call this abstract map dot simple immutable entry. Now if I'm going to call this, how it is implemented internally? How it is implemented? Entry dot get a key, and we are loading this particular key, and internally entry dot get value, the value we are trying to set into this particular simple immutable entry constructor. Now you can see this is the class we created under this particular abstract map, and it is one of the static class we are having. Okay, this is, we need to understand this. After this, we are going to call get key and get value method to load this particular object. Okay, so back to here. Now I'm trying to return this, and it is trying to return this particular immutable. Finally, now it is trying to return this particular map.entry. Map.entry, because the immutable class internally it is implemented the map.entry only. Okay, map.entry only it is implemented. After this, if the P, whatever the P, it is not a null, we are deleting. Okay, we are trying to delete this particular record. So what is the differences we can identify? The particular first entry and the pool first entry. The pool first entry, it will remove the object, and whatever the object we are trying to remove, the object is going to return. And the first entry record, basically it will return without removing the object. Okay, without removing this particular object, it is trying to return this. So this is important, we need to understand here. Now we are trying to deleting the record. The entry is, it is going to delete it here. So how it is deleting it? Now you can see size we are decreasing and we are trying to check. So it should be p dot left not equals to null and p dot right equals to null. Then it is going to move inside this. So far we are checking here. And now you can see here p dot left not equals to null. We are loading this particular p dot left. Otherwise, we are trying to load this particular p dot right here. So any one of the record we are loading. So because we are trying to do the replacement. So which condition is satisfied basically? That we need to identify. So p dot left. First we'll see p dot left is null or any value. So this particular condition fails. So because when it is failed, we are trying to load the parent. Sorry, right side. So both values are null. Correct. Because of this particular p, the p is the first record. It does not have left and right. Okay. So the replacement is null. So when it is null, p dot parent, it is not a null. Correct. P dot parent, it is not a null. If you see this, because the a value now it is coming from the c value. The p dot parent now we are getting as a child record. So because of this, it is coming to the else section. It is doing the fix after deletion, some method we are calling. After the parent, we are trying to load the left value, and the left we are making as a null. Okay, the left value we are loading, and after loading this, we are trying to set as a null value. So this is the way of deleting the entry record from this particular tree map. So finally, we are returning this particular result, whatever the record we deleted. This is the important information we need to understand regarding this particular pool first entry. Only the differences we can easily understand simply. The difference is basically the get first entry and pool first entry. This will remove the record whatever we are trying to load. Okay, this particular method will not remove. It will not remove. Okay, these are only the changes we can identify. So these four methods will do the same. First object and last object will load here, and we need to discuss about the descending map. How this particular descending map is going to work. Let me comment out these methods also, and finally this methods also we need to comment it, so that then only we'll identify the how this particular descending method is working internally. How this particular descending method is going to work. So descending basically, first it will load the right side value. Okay, first it is going to load the all the right side value. Now if you see, we're trying to call this particular descending map. So if it is null, we are trying to pass this particular constructor. The constructor is going to take care of loading the right side value. Now, if I'm going to print this value under this particular println method. Okay, under this particular println method. Now you can see what happening internally. So these are all the first key and last key we are loading, and this is the descending map, whatever we call. Now if you see this, it is trying to load the from the last to like highest value to smallest value, and this particular line number 34, it is trying to print smallest value to highest value. Okay, this is only the important information we can identify. If you want to make some reverse order, if you want to make some reverse order, we can call this particular descending map. It will try to return the values in the reverse order, and navigable key set, and again so descending key set. Now first we'll see the descending key set, later we'll move on to the navigable key set. Now if you see this, another important method, it is a simple one. So whatever the descending key set we are calling, basically it will try to return the keys we are going to get as a highest value to smallest value. Now here you can see we are trying to get only the keys, and the first key it start with the T, because T is the highest value and A is the smallest value. Okay, A is the smallest value we need to understand here. These are all about the descending map and descending key set. Now we'll go to the last method. Okay, this is the last method which we are having under this particular navigable map, because we already discussed all the method how it is working internally. We'll see navigable key set. The navigable key set here, what exactly it is going to do internally. Now first we'll see the how it is working. So navigable key set, it is trying to provide as a natural order, and the descending key set is trying to give as a reverse order, like top to bottom and bottom to top. So these are all the reverse and forward direction, reverse direction. We can use this particular important section. Okay, so now you can see it is trying to make as a the reverse, or we can call it as a highest to smallest, anything. Okay, here the natural order we are getting here. This is the navigable key sets. Any questions regarding this particular four methods? Whatever we are discussing, first key, last key, descending map, and navigable key set, and descending key set here. So any questions? And finally, we need to discuss these particular methods here. So we need to discuss these particular methods here: lower entry and floor entry, so ceiling entry and higher entry. These are all the important method we need to understand here. So these are all the entry related. So it's trying to use the less than condition, whatever the key we are going to provide, and floor entry, it is trying to return the less than or equals to. Okay. So first we'll identify how this particular floor entry, the lower entry, it is going to work. Now I'm going to comment out the four method what we discussed so far. Now you can see tm dot lower entry I'm calling, and here I'm going to pass the particular character, last character I'm giving. Okay, last character. Now if I'm going to run this particular method, so which character, like which record it is going to return here, this is important. Which record we are going to get? Basically the R record. Now if you see carefully, R record is printing or not. Now you can see here it is printing the R record. So how it is printing this particular R record is important. R record, how it is printing? How it is printing this particular R record? Because here what we are doing is lower, like here the less than condition we are using, less than to 0, and less than to whatever this particular key we provided, less than to this particular key. So the what is the nearest value we are going to get, the value it will return here. Now I will put a breakpoint to line number 21, and we'll run this example in the debug mode, and we'll debug this particular method. So character method is calling, and finally we can call this particular get lower entry. So whenever I'm calling this particular lower entry, what is the method I'm calling? Get lower entry. Okay, so we need to identify what exactly the get lower entry will do. So again we are loading the root record. If I want to find out the lower entry, okay, so what is the value I'm trying to use? Right's condition. Right condition I'm using, and here I'm using the left condition. If any condition is not satisfied, we'll move on to this particular else section. We'll identify how it is going to work internally. So let's observe this particular lower entry, how it is going to work. P, whatever the P we given, this is the root element. What is the root element? C value. So 14.6. After this, we are comparing this particular value. We are calling this particular compare by passing this particular value. Now it will compare and it will give you the values. Now what is the CMP we are getting? 17 we are getting. So it is a positive value. Whenever we are getting this particular positive value, this particular condition will satisfy. Now we are going to load this particular right side. The right side, what is the record we are going to get? Basically the P dot right, if we observe, so R value I'm getting. Okay, R value I'm getting. But what is the value we provided? Basically we provided the key. If you see this particular key as a T we provided. Now again we are comparing. Once we compare this, so 2 we are getting. Again the condition is satisfying. So P dot right. The P dot right, now we are going to load as the T record here. Okay, T record we are loading. Now you can see, so right now this particular P, it's containing this particular T record. Now after this, again we are comparing this. Now if you see, we are going to get an equal. We are going to get an equal. The CMP you can see. The CMP you can see here we are getting as a 0. Why we are getting the 0? This particular key and P dot key, both keys are same. Both keys are same here. So whenever we are getting 0, this both condition will not satisfy. So directly if it is not satisfying here, we are checking this particular else here and P dot left. What is the P dot left contain? So far we don't have any records. So far we don't have any record. Now P dot parent. What is the P dot parent here? Again we are loading the R record. If you see here, we are loading the R record. Okay. R is a parent of this particular T record. Now after this I'm loading the child. The P, whatever the P we loaded here, I'm trying to check as a child record. Now it should match this particular both conditions here. So now you can see we are trying to return this particular parent. So what is the parent we are returning? Something like R record. Okay, the parent we are trying to return as a R record. Now finally we are going to call this particular export entry. So what is doing internally? Okay, what is doing it? We are trying to create this particular simple immutable entry. We are trying to set into this particular immutable entry record. So finally we are returning map.entry. So what is the map.entry we are getting? R record. So why we are getting this particular R record? This is the nearest less than condition. Okay, this is the nearest less than condition. For example, if I'm going to give as a, if I'm going to give as a, now what happening internally? Null we are getting. We are getting null because this is the smallest value. Okay, for this particular here, right now we don't have any other less than value because this is only the smallest record. This is only the smallest record we need to identify here. Getting the point? This is very important. We need to understand how this particular lower entry is going to work internally. Any questions on this particular lower entry method? So we need to discuss this lower entry like this less than condition. The less than condition we need to discuss here. Okay, if you don't have anything, now I'm going to call this particular floor entry. Again, we'll see the differences here. So we'll see this particular differences, basically how it is going to work internally. The floor entry I'm like I'm trying to pass this. Again, the same character I'm trying to use A only. So see the see the values how it is printing. So whenever we are trying to give this, first one lower entry method is returning null. The floor entry, it is trying to return the first record. Because for this particular floor entry, we are going to use less than or equals to. For lower entry, we'll use only less than. Okay, we'll use only less than. This is we need to understand here. These are all the important information we need to understand regarding this particular floor and lower entry. Okay, so any questions regarding these two methods, floor and lower entry? Okay, so if it is clear, now we'll move on to the another method what we are having. Now you can see, so we discussed this particular floor and lower entry. Now we'll move on to this particular ceiling. It is only greater than or equals to the given key. And here, what is the higher entry? Only it will check only greater than. So this is the two differences, higher method and the particular ceiling entry. So it is not something like a greater than condition. Whatever we are going to use greater than and greater than or equals to. This is we need to understand here. Now if I'm going to show you, here I'm going to provide ceiling entry. Here I'm going to provide the T. Okay, here I'm going to provide this particular T. And for this particular two records, I'm trying to make comment here. Now if you see this, what is the value we are getting? What is the value we are getting this particular ceiling entry? It is trying to return the T record. Okay, it is trying to return this particular T record. But if I'm going to call this, if I'm going to call this particular tm dot higher entry. Here I'm going to provide the same T. Okay, here I'm trying to providing this particular same T. Now if you see, I'm getting the null. So this particular ceiling entry, I'm getting the T record. For this particular higher entry, I'm not getting any record. It is a null. Okay, it is a null I'm getting. This is important information. We need to understand how it is going to work internally. How it is going to work internally, we need to understand very carefully. Okay, any questions here regarding these two methods? Any questions here? So just we can identify greater than or equals to, less than or equals to. These are all the four methods we are using internally from this particular tree map, because the tree map now it is implementing from this particular navigable map. Okay, navigable map. So these are all the map related example we identified, as well as we identify the some of them are collection related example we identified. Okay, this is all about the collection framework, like part 1 and part 2 we discuss here. So any questions, anyone having any questions regarding this particular example, the collection related, any questions here? Okay, so if we don't have anything, now I'm going to stop the all the collection related what we discuss here. Now I will go to this, like I'm trying to push my all the changes here. Okay, I'm going to push the changes into the GitHub repository what we are using right now. Now you can see I'm trying to open this particular git bash, and now right now we are under the master branch. First we'll see, so any changes we are having, git status, these are all the changes we need to add. Okay, so these are all the modified files we are having, and these are all the new files here. Okay, these are all the new files. Now what I will do here, I'm going to add all the files inside this particular git. So using this particular git add dot we are using, whenever we are using this particular dot, it will try to store all the values into this particular current directory. Now if you see the the status command here, now you can see all the files are added into the local repository. Now from the local repository, we are going to push into the central repository, the GitHub. Okay, now you can see commit I'm adding, and here I'm trying to add the message. The message basically collection framework example. So commit is completed. So once the commit is completed, we need to push the changes. Okay, we need to push the changes. So to push this particular changes, I need to connect the GitHub here. So this is our repository we are having. Now I'm going to copy this link here. Using this particular link, I'm going to push the changes. So git push, I'm trying to paste this particular link. Now whenever I'm trying to paste this, now it is trying to push all the changes into this particular location. So where this particular location is available, right now we are having this. Now if I'm going to refresh this, so collection framework examples. Okay, collection framework example. So for whatever we discuss here, all the example are available under this particular core 07, and now we can see the collection framework. These are all the classes so far we discussed, and here I am adding the txt file also. The txt file will contain all the methods so far, whatever the method we discuss here. Okay, so for whatever the method we discuss, all the example are added here. Okay, for references, I'm giving this particular link here. Now try to go to this particular link and access the whatever we discussed so far here. Okay, any questions regarding this particular GitHub? See, higher entry, if we observe, greater than value we are checking. So this is important. Here we are trying to check. If we are trying to providing the A, because After A, we are having C also greater value, E also greater value, H and R and T. These are all the greater values only. How it is a greater value? So A is containing 65 and B will contain the 66 and C will contain the 67. Now if you go back to here, the T around it will contain some 90. So I am not providing the exact value, just I'm assuming if it is 90. So it here 90 greater than 65. It is satisfying only, right? It will give you the value. But because of that higher the higher entry, I'm checking the T. Right now T is the highest value. T is the highest value for this particular T. We don't have any other record. Because of that, we are returning null. Because of we don't have any records here. If you are trying to use the Z, now the Z will return. But right now, up to the T only, we stopped here. Okay, this you need to check the condition. Greater than condition, how it is going to work, and less than condition, how it is going to use. Okay, so any questions? Any other questions here? Okay, so if you don't have anything in, now go to this particular, whatever the link I given earlier. So use the same link for this particular collection framework classes, whatever we used it so far here. Okay, so tomorrow we are going to discuss another important section, Spring related example we are going to discuss. We'll start from the basic. What are all the different information we need to identify in the Spring we'll discuss here. Okay, we'll discuss about this particular GitHub once we completed the all the example on the Spring and Spring Boot, how it is going to work this particular Git, and how we can create an account, how we can connect it to the local branch, and what are all the command we are having to work on this particular Git related. We'll discuss the Git related example once we completed the Spring and Spring Boot.
Sir,
Yes.
in collections, can we just overbrief what is the differences between all these list, set, map, whatever we have discussed right now, sir? Just overview, not so much detail.
Overview, basically, if you go to this particular array list here, we are going to provide the insertion array, like how we are going to insert the same way. But array list and linked list will work on the same. But linked list, how it is going to work, it is trying to use the data structures. These are all important. Array list is going to use the object array, because we are going to store the object array. Linked list is not going to use the object array. It is going to use the node concept here. Okay, and these are all the two implementation, because it will also give you the same how we are trying to inserting the same way only we are going to get the data. But the difference is here, by loading the object is array list, we are going to provide, for example, array list we are going to store inside this particular elements. Okay, elements is having object array. And here, if I'm going to load this particular element, we are using this particular references here. Now you can see directly we are going to provide the index. Okay, whenever we are providing this particular index, now what happens internally, whenever we are giving this particular index, directly we are loading the value. So for example, I'm having the values like this, 0, 1, something I'm having here, I'm trying to provide it, 0, 1, 2, and 3, so 4, 5, and 6. I want to load this particular fourth record. Okay, I want to load this particular fourth record. Now what we will do, we'll give you the index, like directly we'll try to provide this particular number 4. This number 4, now it is going to work as the index here. Whenever we are giving this particular 4, this value is going to load it from this particular array. This array we can identify as the elements. Okay, this is important. So this section will work under the array list here. Now if we come back to the linked list, so linked list basically it is going to work on this hash code, key, and next node, and it is going to have the relationship like this. Okay, it is going to have this particular key value and something like next node references. Here previous node and value and next node, and same thing previous node, value, and next node, and internally it is going to create node concept like this. So this will work under the linked list. Whenever it is working like this, now if I want to load this particular value, the value it is containing something like 10. I want to load the 10. Now what happens internally? First it will search this particular node, and later it will search this particular node, and later it will search this particular node. So searching operation is going to take some time here. Getting the point? So directly we are not going to work like this. So here we first we'll see this, and later we'll see, and if it is not matched here, again we are going to discuss this section. Okay, the linking we are having like this. Next node is connected to the previous node, and the same thing it is connected to this particular previous section, and the same it is going to connect it. This is the search operation and in search operation. Once this node I'm trying to delete. Now what we need to do? We need to connect it to this node. We need to connect it to this particular node. So this is the linking is going to take some time here. But here the object array removing or loading or inserting is not going to take much time, whatever this particular time is going to take in linked list. This is the differences. The array list and linked list. And coming back to the set related. Set related we discuss here has set and linked has set and tree set. These are all the three classes we discussed. So hash set and linked hash set, internally it is going to use the hash code and equals method basically. Equals method we are going to use on the keys, and hash code also we are going to use on the keys. Why we are using the hash code? After generating the hash code of this particular key, we'll identify the node location, because these two sections internally they are trying to use the node array. Getting it? They are trying to use the node array. Internally, it will try to create a node object. The node object basically it will look like this. So hash code, key, and value, and next node. Getting the point? Here we are going to use hash code and key, value, and here we are going to discuss about the next node. Same thing, but here it will work under the hashing mechanism basically. These two, but advantage of this particular linked list, sorry, linked hash map, like a hash set here. What is the advantage we are going to get? We discuss internally. It is going to use before and after. Okay, before and after. This particular before and after, this mechanism is not implemented under this particular hash set. Hash set internally, it is going to use on the hash map. And another advantage, we will try to use only null keys. Only one time we can use this particular null keys. Getting the point? These are all the some differences we discuss here that we need to understand. Some classes this is going to use the null keys, and some classes if you're trying to insert the null, it will throw an exception. Okay, that advantage we are going to have inside the hash set and linked hash set. But the linked hash set will contain the one more advantage basically. We are going to load the same insertion order. How we are inserting the data in the same format we are going to load. But for this particular hash set, we are not going to get something. Like how I'm trying to insert it. For example, 10, 20, 30, if I'm trying to inserting into the hash set, will not get the same order. But the same order we can get internally inside this particular linked hash set. Okay, so tree set. Tree set basically we already discussed that it will try to connect with the tree map. It is going to provide the ascending or descending order. Ascending or descending order. Okay, so this is the main information we identified. Any questions? Because these three classes only we use inside this particular tree map, and the same classes we are going to use in the collection, like the set related example. But only the difference in the set related will not focus on the values, but in the map related example we'll focus both key and value. But the keys are is going to play very important role in the two sections, like in the set as well as in the map. Any questions? Okay, So this is very important example we discussed here. I'm requesting here. I hope all the videos I already uploaded into the whatever the playlist we are using here. Now go to this particular. Let me stop this. Okay, so you can see here we are having from 1 to something like a 15, like 15 videos we have. So try to focus on this particular 15 videos. You can get more about this particular all the classes. Now the legacy classes, we'll try to discuss the legacy classes whenever we are having the time here. Like in the Spring on the Spring Booted, we are going to discuss this particular legacy classes. So there I will explain the how the legacy classes, because we need to discuss this particular the important information. So one of the important information has table, okay, has table, and so vector. Getting the point. So has table and vector, because most of the cases we are not using. Okay, but anyway, I will give you the overview how it is going to work internally. But this section will discuss in the Spring or Spring Boot, because this important we are going to cover based on our example here. So this in the real time we are not going to use, just for understanding the differences what we have right now and what are the previously we used here. Because if I'm going to show you this particular hash table and vector, it is introduced from the beginning onwards. Vector. Now you can see it is coming from the 1.0. Okay, it is coming from the 1.0. Like from beginning of this particular collection framework, it is implemented. So vector is a class. Internally, it is trying to extending abstract list, and it is implementing the same whatever the list. But some differences we are going to have that we need to discuss here. So if you're having the time, you can discuss, like you can go through the classes, what exactly it is implemented, and what are all the constructors here. Getting the point. But these classes are not required in our whatever the applications we are trying to implementing currently. Okay, but I will give you the overview of this particular classes, how it is going to work internally. Any questions?
Can you please copy the links to the chart?
Which link you are talking about?
The YouTube one you just.
So I hope I already given. I think you cannot copy this link from here. Can you try?